This question is just a set of solutions for a test that you guys did. It was a statistics question. It was a section B, context and applications question. So I suppose we'd refer to these as the longer set of questions. This one was about a triathlon. You can see there it says that the King of the Hill triathlon race in Kinsale consists of a 750 metre run, followed by a 20 kilometre cycle, followed by a 5k run. The questions below are based on the data from 244 athletes. So we can start by maybe underlining some of the information that we might use or might be useful to us later on. So the fact that there's 224 athletes, that might be significant. It might not. Marie is analysing the data from the race using statistical software. She has a data file with each competitor's time for each part of the race, along with various other details of the competitors. Marie produces histograms for the times for the 3 events, and here are the 3 histograms. So the first thing I want to do, just even before we take a look at the question, is just histograms versus bar charts. So I suppose the key thing here, there's different kinds of data that you can have in statistics. We're dealing with numerical data because the answers that we're given to the questions there are in number form. So we're dealing with numerical data, and when we're there are 2 kinds of numerical data that we can have. We can have what's called continuous, or we can have discrete. And histograms are used to represent continuous data, and bar charts are used to represent discrete data. So the difference between continuous and discrete, well, basically continuous data means decimals. Or if you can fill in, it doesn't have to be very advanced decimals, but if you can fill in the gaps in between. So for example, when we talk about time, well, time we say is continuous because you could have 1 minute, or you could have 2 minutes. But to be fair, you could also have 1.1 of a minute, or 1.2 of a minute, or 1.22. So because we can get down into the nitty gritty of things and really get tight in terms of how accurate we want to be, we would we use this, we call this continuous data. An easy way to represent it. It's not foolproof, but we can just say if there's decimals involved. We'll take a look at the histogram in a second. A bar chart refers to discrete data, and we'll say just as maybe something to latch onto, we say that there are no decimals. So really common kind of a thing is how many people like a particular colour. If you're talking about people, well, you can't have 2.5 of a person. So that's why people, or if you're counting the number of people involved in something, it's often, and you're displaying that information, it's used with a bar chart, or it's displayed with a bar chart. So histograms, when they're drawn, well, they've no spaces between the bars. But bar charts do have spaces. So obviously the fact that there's no spaces between the bars means that everything is included, all the decimals, all the nitty gritty, the accuracy is really there. But over here, when we say that they do have, bar charts do have spaces, well, that means that we're not including the decimals, so we're just dealing with really whole numbers. So this question here for us, you can see that these are the 3 histograms that were given. Very similar to bar charts. I suppose, but we've explained the difference there. There's a couple of things that I just want to point out to you, some things that weren't noticed by students, or sometimes aren't noticed by students. The interval here, it does go 10 to 14, but I suppose what you're expected to see there is there's a 12, a 16, a 20. So each interval is actually equal to 2. Okay? And if you have a look across at the cycle histogram, the same thing is happening. So you've got 30 to 34, and then this little gap in here is 32. Okay? So the interval for all the histograms is 2. You can see there's your 18, and you can. But I suppose it's something that next time you come up against a histogram and you have to take a look at it and you're asked about questions on it, that is one of the first things that you should take a look at. Are the intervals the same across all of the histograms, etc., etc.? The other thing that I want to draw your attention to as well, please, is just the scale here. And again, you should be watching out for things like this. The scale isn't quite the same for all of them. You can see for the swim and for the run, it goes up in 10s. However, for the cycle, it actually goes up in 5s. And in terms of numbers of, I should also point out as well, the scale along the bottom here for each of the 3 different events. Well, this is going from roughly 16 to 38, whereas this one here is going from roughly 30 to 60, and this one here is going from 10 to about 32. So you have to be mindful of the different scales that are presented to you and how that might affect the answers that you give. So let's take a look at some of these questions. So it says, use the histograms to complete the following sentences. The event that on average takes the longest to complete. So that question there, you need to take a look down here, like I've just pointed out to you, the times. So I suppose the longest competitor took 38 minutes to complete the run. The longest competitor took 60 minutes to complete the cycle and 32 minutes to complete the swim. So it's an analysis, or taking a look at the scales along the bottom, along the x-axis, so to speak, that will allow you to answer that question. So our answer here is the cycle, because it took longest to complete. The next question. In all 3 histograms, the times are grouped into intervals of, well, it's intervals of 2 minutes. Sorry. It's intervals of 2 minutes. And again, I've discussed where you find that already. The time of the fastest person in the swim was between, well, you can see there it's between 10 and 12. Just take a look over here at the swim histogram. So, fastest, well, if you're the fastest, that means that you were very quick in terms of completing that particular event. So, the fastest person is actually between 10 and 12. Okay. Very often people think it's going to be up here. It's just make a little error. They think it's between 30 and 32. So the median time for the run. So before I answer this question, I want to just give you a little reminder. Go back and talk about some general information that you know on histograms. You've got 3 kinds of histogram that you need to be familiar with, or I suppose I should say shape of a histogram. You've got the one that looks like this, and this is called normal. You've got the one that looks like that. That's called left skewed. Sorry. And then your final one that you guys need to know about is right skewed. So, on a if you haven't come across this before or you don't remember it, well, there's the start of it. There are the 3 different kinds of distribution that you need to be familiar with. However, there's extra information that you also need to know. So I'm going to talk to you about the normal distribution. What's special about the normal distribution is if I draw a line straight down the middle, that if a distribution is normally distributed, the mean, the median, and the mode will be approximately equal. So they'll be approximately straight down the middle here. Okay. Now, before I talk about the other ones, I'm just going to apply that to this question. We're asked here, the median time for the run is approximately what? Well, if we take a look at the run histogram, you can see that it's basically normally distributed. So that means going straight down the middle, halfway between 24 and 26 is 25. You can see there, that's where I'm getting my answer of 25 from. Even though it's not needed for the remainder of this question, just to give you the information so that you have it. If you're dealing with left skewed, well, the highest point on the left skewed, that will represent the mode most often. Then you'll have the median, which is in the middle, and then you'll have the mean. If you take a look at right skewed, it's actually the same thing, just in reverse. So you'll have the mode, then the median, and of course the mean. Okay. So the last question then here says the event, this is down here, so the event in which the times are most spread out. So most spread out. So again, that means you're going to have to take a look at these intervals here. Sorry, not the intervals, but the scales, I think. Most spread out, well, from 10 to 32. So the range there you could say is 22. From 30 to 60, so the range there is 30. And from 16 to 38. So you can see there that the range, the biggest range, is going to be for the cycle. So that's where the answer. So spread out, if you remember, that kind of is an indication that you're dealing with either range or standard deviation. Okay, so I'm just going to go with the range to help me answer this one. So next part of the question. So we can tell straight away that this is a scatter diagram. So Marie is interested in the relationship between the athlete's performance in the run and in the cycle. So you can, again, a couple of things you're going to take a look at. So you've got the cycle time, that's this axis down here, and you've got the run time, that's this one over here. And then each dot, so for example, you might say that, and we're going to use this in a second, this dot here means that somebody did the run, or sorry, the cycle in, roughly speaking, maybe 58, 59 minutes. And did the cycle in roughly 31, or sorry, the run. So, first part of this question says the correlation coefficient between the times for these two events is one of the numbers below, and you have to select which number you think it is. So I'm saying that the correlation coefficient there is about 0.77. Okay, so that's where my answer of B is coming from. So why am I saying 0.77? Well, first thing I'm going to do, I'm going to put an oval around the data. I'm just going to take another page and give you a little run through. There are two things that you must mention when you're talking about correlation. Is it positive or is it negative? So if it's positive, it will roughly be going like that, or like that, or like that. Okay. If it's negative correlation, It could be going like that, or like that, or like that, or like that. And then you have to mention whether it's moderate, weak, or strong. So weak, moderate, or strong. So if you remember from what we've looked at on this, a weak correlation means that the data is very, very spread out. Okay? So the wider the oval that you have, the weaker the correlation. If it's moderate, it's a little bit closer together. And if it's strong, be along those lines there. So in actual fact, the one that we have in this exam question, it's actually right between, when we compare there, it's actually right between moderate and strong. So I suppose the other thing that you need here though is you need to know a little bit about the numerical values that go with correlation. So the first thing to remember is that correlation is from -1 to +1. Okay? We can break down, I'm just going to flip this over, we can break down correlation. Now this is quite broad, but so -1 to +1. And what we can say is that obviously if the number is negative, well then it's negative correlation, and if it's positive it has a positive correlation. But if we go from 0 to 0.25, well this is what we would say is weak. If we go from 0.25 to about 0.75, we'd say this is moderate. And if we go from 0.75 to 1, we'd say that this is strong. So if you just take a look at the numerical values that I'm talking about, in the exam question I went for an answer of B, which is 0.77, and 0.77 was actually right on that borderline between moderate and strong, which would make sense given what we just said. If we take a look at our oval around that and the shape of it, and then compare it to the two ovals that we expect from moderate and strong, so this one being moderate, this one being strong, what we're given in the exam question is kind of just between the two. So that's why I went for my 0.77. And obviously I went for positive because they're both, the data in the question and the scatter plot is clearly running in a positive direction. So we'll move on a little bit. It says Frank was the slowest person in the run. How many people took longer to complete the cycle than Frank did? So Frank was the slowest person in the run. So you can see up here I've identified Frank. He's just here. I have a little dot going over him, but he's just right here. So he was the slowest person in the run. Now this here represents the run. If you're the slowest in the run, it means that it took you the longest to complete. So he's the highest dot for the run. So then if I want to know his time in the cycle, I just drop him straight down, which would be roughly there, shall we say. But that's not what I'm asked. I'm actually asked how many people just took longer. So you can see with the red line, I just count the dots. 1, 2, 3, 4, 5, 6. So 6 people took longer than Frank. The question goes on then and it says, Brian did not enter the race, but suppose that he had, and suppose that he completed the cycle in 52 minutes and the run in 18 minutes. Explain why his performance would have been very unusual. So again, what I did was, I decided, well, I'll mark Brian out here. So I marked him down, so that's his red dot there. And as you can see, I've got my oval around the rest of the data. Brian is very unusual. Okay? So that's all that you need to state. It says there, Brian is an outlier, and it would be important that you mention that word outlier because he is unusual from the general body of information. Both his times are different to the majority of people in this group, and that's a fine answer, but I definitely need to see the word outlier. Okay, so we're moving on to the last part of the exam question. So here we've got a back-to-back stem and leaf. So it says, Moira already knows that the male athletes tend to be slightly faster than the female athletes. She also knows that athletes can get slower as they get older. She thinks that the male athletes in their 40s might be about the same as the female athletes in their 30s. She decides to draw a back-to-back stem and leaf of the times of the two groups in the swim. There are 28 females and there are 32 males. So the first thing I suppose we're going to take note of is that there's a different number of females and males. Also, and you really need to get into this habit. Very often people ignore it. You're dealing with different age groups as well. Okay. So that's our data. You can see there that I've just got an idea of the two shapes of the two sets of data that I'm dealing with for the females and the males. Sorry, just let that focus. So now I can move on. Describe what differences, if any, there are between the two distributions above. So I think, to be honest with you, obviously there's a difference in the number of males and females, and if you were stuck and you wanted to write that down, you could. Obviously there's a difference between the age cohorts that are being looked at, but I think, to be honest, given that those two things are given in the exam question, I'm not so sure that they would get you full marks. I think maybe the first thing that you should look at is that they have different distributions. Okay. So the males, normal distribution, and the females, well, they've got a right skewed distribution. Other things, and I'm not going to calculate them, but other things that would be worthy of marks would be if you calculated the mean for each group, they will be different. If you calculated the mode, if you calculated the median, or if you calculated the standard deviation, or of course the range. And the range is probably the easiest one of all of them. It's very, very quick, so they'll have a different range. But remember, when you're asked for differences, or if you're asked your opinion on something, you must always tie it back into some sort of statistical measurement. So the last part of the question is here. Moira drew the diagram because she thought that these two groups would be about the same. Do you think that the diagram would cause Moira to confirm her belief or to change it? And give reasons for your answers. Well, first things first. Moira drew the diagram. You can see I've already got it underlined here. This is what she thought. So she thought that these two groups would be about the same. Now, from looking at the exam question, the part before it, we can see first of all that the two distributions are going to be very different. One is right skewed, one is normal. That means that the mean, the mode, the median, the standard deviation and the range, they're all going to be different. So our answer here is she thought that they were going to be the same. Do you think that this would cause Moira to confirm her belief or change it? Well, it will change it. That's what we think. And then of course here, look, give reasons for your answer. It isn't, remember, when they want reasons for an answer, they want something statistical or mathematical. They don't just want a general run-of-the-mill answer. What's required there is, you've looked at, describe what differences, if any, there are between the two distributions. If you, for example, said that males and females, you talked about the shapes of the two distributions. Well then, for this bit down here, you might mention that the means are different. But don't forget that you must calculate them. Don't just make a statement. Show the examiner that they are different. So show the maths that's involved. You might decide to mention the mode. You might decide to mention anything that you've actually already talked about here: the median, the standard deviation, or the range. Now, I have to say, I think the mean and probably the median are the two best ones to go for there. Okay. Again, I'm not going to calculate them out for you. I leave that to you. We've done that in class several times. But again, remember, last thing, if you're asked to give reasons for your answer, they must be statistical or mathematical, not just what you think, or talking about what you think she had for breakfast and why that might have impacted on what she was going to do, or anything like that. It's all about the maths.